Okay, hello. Today I'm gonna be differentiating without differentiating. Someone's gonna ask, hi, how can you even do that? Differentiating literally means differentiating. Many students don't understand the concept behind differentiating and how the differentiating formula comes, like how it's derived. Basically, there's a topic called limits, which deals with how f of x changes when x approaches a certain value, and using that you can differentiate without even using the formula. But to do that, first you need to understand what even is differentiating, right? So when you differentiate, you basically get the gradient of a particular point. But well, suppose I draw a curve here. How can you get the gradient here? The gradient is ever changing. Like you'll say, oh, you'll draw a tangent, but you're not gonna get an answer. Like you'll get an answer with that, but it's not you or me. I can't explain it better. Either way. So what differentiating basically does, I mean you're not doing it, but what the formula does is it breaks the said curve into infinite small parts, each of the length 1 over infinity. And when you are finding the gradient, you're finding the gradient of this, you're finding the gradient of a point, not even of a segment, of a point. It's very abstract, so I'll show you how. Many people won't believe that when I say a curve is basically infinite straight lines. Many people will say, no, you're stupid, what are you even saying? But I have a way I can prove that one curve is infinite straight lines. Suppose I have a function f of x, which basically says that f of x is equal to a polygon with x sides. So first I'll put f of 4. So I just want to make it a square. I'll make it a square. Does this look like a circle? Like, does it look like it has any curves? No, it's a square. How can it? Right. So I'll make f of 6. Okay, my bad. F of 6. That will be a hexagon. Does this look like a circle? You'll say no, it's a hexagon. How can it be a circle, right? Now f of 12. I didn't count. I don't know how much that is. It doesn't look like a circle. But, like, sorry for the bad drawing. But basically you can see the transition. It's going from a fully cornered shape into somewhat of a curve. And now I want to write this as limit x is approaching infinity. So as my x value is getting closer and closer to infinity, my f of x, so the shape I'm getting is a circle. So as my x is getting closer to infinity, my shape is getting closer to a circle. So that will state that a polygon with infinite sides will basically be a circle. And a side has to be a straight line. So infinite straight lines can make a circle, which is a curve. That basically shows how one derivative curve, for example, or any curve, rather just an equation of a line, is basically infinite straight lines joined together. A curve like this can also just be straight line, 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 straight line. Something like that. And you're finding the gradient of each small segment or compartment. Okay, that was a lot of talk. I'll just come back to the actual differentiating without differentiating. Suppose this, I have no idea what the equation of this is. I have no idea. But suppose the equation of this is x squared plus 2x plus, what do you want? Plus 3. Because why not? I can keep it this. I want to find the gradient of this at point x. Let it be any value. Now, basically from what I just said, I need to find the gradient of the small segment which has a length of 1 over infinity. How can I do that? How is that even possible? So, a point A is what I'll take. I know I just wrote x, but I don't want to take x because you were confused with this. So the point will be a comma, since this has to be the y value, this will just be a square plus, what's this? My bad. A square plus 2a plus 3. And I want to take one more point. Now this is important. A plus h. Now you're going to say, what is h? saying h is 1 over infinity, because I want the length of the compartment of the segment to be 1 over infinity. I want it to be infinitely small. So this is going to be a over h. This will be a over h whole square plus 2a plus 2h plus 3. And now this basic math, something everyone's learned in their life. The gradient formula. What is the gradient? Gradient is basically delta y over delta x, or dy by dx. This is what you learn in differentiation. That basically represents this. Oh yeah, dy by dx is basically delta y by delta x, where the delta approaches to 0. Approaches, it's not 0, it approaches to 0. Okay, either way, that's fine. So basically, this minus this, right? Because it's delta minus delta. So you're gonna have a square plus what? H square plus 2ah plus 2a plus 2h plus 3 over a square plus 2a plus 3. That's what you're gonna have. No, sorry, I'm stupid. You're gonna have a square. What's wrong with me? Minus a square minus 2a minus 3. This is going to be a delta y, and a delta x will be a plus h minus a. So what you're going to get in the end is going to look something like this: h square plus 2ah plus 2h over h, which is going to be h plus 2a plus 2. This over here is my differential. Now I'm going to say, I stupid enough. You just divide it by 0. H is basically 0. I'll say no. H is 1 over infinity. You can divide by 1 over infinity, but you can't divide by 0. So this is still creditable, it's still plausible. Now this, as I said, is 1 over infinity, right? H. I don't want to take it. I won't take it. What are you going to do? I'll just write this as 2a plus 2. Because this value is basically negligible. Like, what is 1 over infinity, right? This actually arises, it causes a problem in calculus. There's going to be an upper limit and a lower limit of an error every time you differentiate. But we're not taught that in school, so it's fine. Either way, 2a plus 2 is going to be a differential. And a is basically x. 2x plus 2. And, well, if you're a geek or you have the differential formula, you just differentiate this. This is going to give you 0, 2x plus 2. You just differentiate it without differentiating. Thank you.